Hey guys, I'm Jackie and I'm a postgrad student here at Curtin. We have heard you've been having a bit of a problem with some equilibrium, in particular with whole buffers things, so we're here at the new Resources and Chemistry precinct at Curtin, and we're going to be having a bit of a talk to Stuart Bailey, who's an expert on the subject, and hopefully that will sort some problems out for you guys.
Hi, I'm Stuart Bailey. I'm a lecturer in chemistry at Curtin University. Today I'm going to talk about equilibrium. Many chemical processes involve equilibrium. One of the most important ones is buffers. Buffers provide an excellent illustration of the principles of equilibrium. Buffers occur in numerous situations, ranging from living cells to swimming pools, from food and drink, water supply, and many different types of industrial operations. So, what is a buffer? We can define a buffer in one way by looking at what it does. A buffer resists a change in pH, and we can relate that back to the hydrogen ion concentration of a solution. I want to illustrate this with a simple experiment here. When I add hydrochloric acid from my burette to this solution of water, which I'm going to add a little universal indicator, I see that we have the typical colour of a neutral solution in the water and a slight addition of hydrochloric acid solution, and the water has already become acidic and turns a red colour. If I repeat this experiment using a buffer solution, we start off again with the neutral colour of the buffer solution, but when I add the hydrochloric acid, what I see is that it takes a substantial addition of hydrochloric acid until I have reached the red colour, which shows how the buffer resists the change in pH. If I repeat this experiment using the addition of a strong base, again I see that using water I go from the yellow colour of the neutral solution, and a small addition of sodium hydroxide gives me the blue-violet of the basic solution. Now, with the buffer solution, again, starting from the neutral colour, addition of sodium hydroxide requires a much larger addition in order to reach the blue-violet colour of the basic solution. Again, showing how the buffer solution resists the change in pH upon addition of the strong base. We could also have defined a buffer in a more chemical fashion by looking at its composition. Buffer solutions contain a mixture of at least two solutes, an acid-base conjugate pair. A buffer must contain both the weak acid and its conjugate base. We can illustrate that using acetic acid. The equation for the dissociation of the weak acid, acetic acid, is shown in the subtitle. A buffer solution must also contain the conjugate base of acetic acid, the acetate ion. For example, we can get this from sodium acetate. Some people find it unusual that a solution may contain more than one solute, but in fact this is very common. A cup of coffee may contain, as well as coffee, sugar and perhaps milk, which would make 3 solutes. So to make a buffer, we could add 0.5 moles of acetic acid to a flask, then add 0.5 moles of sodium acetate, and make the solution to 1 litre with water. This means we have a number of equilibria all interacting. We have the dissociation of acetic acid, the dissociation of sodium acetate, and we have the water self-dissociation equilibrium. All of these equilibria affect each other, with the result that a stable concentration of H+ is maintained. The buffer resists changes in pH by addition of strong acid and strong base. If we add strong base, it reacts with the acetic acid. As long as some acetic acid remains, the pH changes little, but after all acetic acid has been consumed by reaction, the pH increases. Similarly, if we add strong acid, it reacts with the acetate. So long as some acetate remains, the pH changes little, but after all acetate has been consumed by reaction, the pH decreases. We find buffers in many aspects of our everyday lives as well as technical applications. For example, you may have seen skincare products, soaps and shampoos that are pH balanced. This is done by the use of buffers.
Hopefully that helped you guys with some of the issues you've been having. If you have any more issues with buffers or equilibrium in general, just head to the links at the end of the video, and good luck with exams, and we'll see you soon.